This lesson we're going to look at factoring, beginning of factoring, and the method we're going to use is called the greatest common factor. Before we get into factoring, I just want to build up our context of understanding what factors are and divisibility. So that's the point of these first 9 questions, is just to review some previous knowledge of factors. So number one, what are the factors of 6? So there's a couple of different ways of multiplying to get 6. So we could have 1 times 6, or we could have 2 times 3. So I'll just list those all down. So again, we're understanding that factors are things that multiply to be a product. That's kind of the point of that first one. Number 2 is also just a review of what is a prime number. So a prime number is any number. I could also put any expression. So any number, because expressions represent numbers. So any number whose only factors are 1 and itself. Okay, so number 3 there is 17 a prime number, and the answer is yes, because no other number can divide into that evenly. We can think of it that way, but its only factors are 1 and 17. So when we start talking about factors, it's quite natural to start thinking about divisibility. So it may be good to review some of those divisibility rules. So how do you know if a number is divisible by 2? And that's, I think most of us know that one. That is if the number is even. All right, so if it's even, it's divisible by 2. And by even, again, we're just looking at the last digit, really, the ones, and to see if that's an even number. So probably one that's not widely known is number 5. So how do you know if a number is divisible by 3? And that is if the sum of the digits is divisible by 3. So if the sum of the digits is divisible by 3. So for example, 51, is that divisible by 3? And the answer is yes, because if you do 5 plus 1, that is 6, and the sum there, the sum of 6 is divisible by 3. All right, how do you know if a number is divisible by 4? And that is, this one's not as necessary to memorize, so you can do 2 twice, but if the last 2 digits is divisible by 4. So for example is 7,520 divisible by 4, and the answer is yes, because those last 2 digits are divisible by 4. All right, number 7, how do you know if a number is divisible by 5? The last digit, or I guess the ones column, right? The last digit is 5 or 0. Number 8 is not quite as necessary to know, but how do you know if a number is divisible by 6? It's even, so that means it's divisible by 2 and divisible by 3, and that should make sense that it does both. So if divisible by 3. So if both 2 and 3 work, obviously 6 has to work. And probably the one that's most widely known, how do you know if a number is divisible by 10? The last digit is 0. All right, so the point of those first ones is to understand again what a factor is. A factor is things that multiply to be a product. Number 1, and so that makes us think about divisibility as well. And so if things are, all those factors divide into the product. So it is an important idea to understand how do you know if something's divisible or not. So those are kind of the basic ones. The second thing to review is understanding what factors are in a product. So we already did some of these, but this is just a quick review of how do we find the product? How do we multiply these? Because what we'll be doing is going the backward process. So on this one, we're going to do each one of these terms are going to be multiplied by 2a to the 8th. So again, the coefficients 2 times 8 is 16, a to the 8th and a squared. If we expand that, we have 10 of them. And then we do that to the next one here. So 2a to the 8th times the negative 7a, so subtracting 14, a to the 9th. And the final one, 2a to the 8th minus 3 is negative 6a to the 8th. So what we need to think about is going backwards. How would we go from our product back to the factor? And really the key is finding what number that is out there, because we multiplied each of the terms in the parentheses by 2a to the 8th. So how do we find that 2a to the 8th? And so what we'll notice is that we're going to first look at all those coefficients and see what's the biggest number, the greatest number that can divide into all those. And again, same thing when we're talking about the variables there. Okay, so number 11, we're going to multiply 5 times each of those terms. So that's 35x squared plus 25x plus 35. And the point on all of these, 10 through 13, is that noticing what that factor is on the outside. So on number 10, that factor is 2a to the 8th, so it's a coefficient with a power. Number 11, it's just a whole number, so 5. So when we go factoring, sometimes it'll be just a number, sometimes it'll be a power and with a coefficient there. And number 12, sometimes it's just a power. And so 7 squared, we're going to distribute that. So 7c to the 5th plus 4c squared. So in this one, again, this one is just a power. So how are we going to look at this and figure out what that exponent is? And what you can notice on if there's a variable in each term, it's always the smallest exponent. Hopefully you notice that on 10, 11, and 12. It's so on this one, that's part of it, because there's a c squared in both of those. On number 11, there's not a variable in each of those, each of these terms here, so there won't be a variable on the outside. And then number 10, there is a variable on each of them. So we take the smallest variable exponent for the variable, so that's a to the 8th. All right, and the last one, reviewing what happens when we multiply by a negative. So that's negative 35x to the 10th minus 63x to the 7th. And the point of that one is when we distribute a negative, it changes the sign values. So going backwards, if we factor out, a negative, it's going to change the sign values again. 14 and 15 are trying to, again, just develop that understanding of distributing. So when we multiply 3x times both of those, right, that's going to go in front of the 4x, and then 3x times 5. So again, that's just trying to get an idea in our head of how are we going to go from this to this way. Okay, so again, these are review questions. So we did 3x times both of those, that factor on the outside, and then again, if you multiply those, you get 12x squared, multiply 3x times 5, and that's 15x. But the point, again, of this question is, that's kind of review, so but the point is, how are we going to go backwards? How are we going to find this number that's part of each of those terms? And so number 15 does the same idea. This one's going backwards. It's kind of done for us already, so we have this product. So how are we going to factor that? And so we're going to try to find the biggest number that divides into 45 and 18. So we're thinking in terms of divisibility, and that is 9x. So you'll notice this right here, 9x times 5x is 45x squared, and 9x times 2 is 18x. So the question is, how are we going to come up with that 9x? And if there's a 9x in both of them, we can factor it out. Okay, so 1 through 15 is just to provide a context of what we're trying to ultimately do. So let's go ahead and look at some problems. So that helped us get the framework of what we're doing. These are the actual problems. I'm going to ask you to factor by using the greatest common factor. And so again, you're looking for the number, and variables represent numbers, so the number or variable that we can divide into each term. That's what it means to be a factor. Common means it has to be the same in all of the terms. Okay, so the adjective there, common, just says, all right, all the factors have to be the same for every single term. And the greatest just has to refer to, we want to find the greatest number that divides into every single term. All right, so a couple of examples here. So factor 3xa plus 2a. So we look at the numbers, those coefficients, and is there a number that divides into 3 and 2? Other than 1, 1 doesn't really do a whole lot when we factor. So the answer is no. And then we look at the variables. So if we look at the variables, there is an a in both of our terms. Okay, so when there's an a in both of our terms, that's what we're going to factor out. You're kind of dividing it out almost. Now, when you do your work, you don't have to show it quite like this. So we're going to divide each of those terms by that and multiply. And when we multiply and divide by the same thing, that's 1, so it doesn't change the value. You can, when you do your work, skip this entire step. If you want to just do that in your head, that is fine. But really, that's what you're doing in your head. So that expression 3xa plus 2a, if we factor that, that's the same value as a times 3x plus 2. One other quick thing, again, we're going backwards. If you multiply all your factors, you should get back up to here. So that's one way of checking your work. A times 3x is 3xa, and then a times 2 is 2a. So you can check your work by just distributing it back. All right, so the second example, a little bit more challenging, but we'll do it in 2 steps. So what's the greatest common factor of 15? What's the biggest number that divides into 15 and into 10? And the answer is 5. And so we'll put that 5 on the outside, and we'll also divide by 5 on both of those terms. And then we'll do the same process with the powers. What's the biggest exponent? You can think of it, I guess, that way. What's the biggest exponent that we can divide, or power we can divide into both of those? And if there's an exponent in every single term, that's what we're going to look for. And so on this one, that's x squared. So x squared is the biggest because this is x to the 5th. I guess we could expand it. And x to the 5th, there's 5 of them. And x squared, there's 2 of them. So the most in both of them is 2. So that's how we get that x squared. And then we'll just go ahead and simplify that. So if we go to simplify that, 15 divided by 5 is 3. And then x to the 5th divided by x squared is x to the 3rd. And we'll do the same thing on the next one. 10 divided by 5 is 2. And x squared divided by x squared, that is just 1. Anything. And so again, that's the factored form, and we can double check that by multiplying these back. So that makes sense that we're dividing through this process, because really the opposite would be multiplying when we distribute that back. So 5x squared times 3x to the 3rd is 15x to the 5th, and then 5x squared times 2 is 10x squared. So again, to check our work, we distribute, which is really a multiplication. So it makes sense that factoring is kind of a form of division. All right, so maybe a few practice problems together. All right, so let's look at number 16. So what's the biggest number that can divide both into 14 and 35? And the answer is 7. And then what's the most number of y's we can divide into y to the 12th and y to the 7th? And that is y to the 7th. Okay, so I'm going to copy down 14y to the 12th minus 35y to the 7th. Okay, so if I divide both of those by 7y to the 7th and simplify it, we will be done. Okay, so I'll bring this straight down. So 14 divided by 7 is 2. Y to the 12th divided by y to the 7th is y to the 5th. and then 35 minus, or divided by 7 is 5, and then y to the 7th divided by y to the 7th is 1. All right, number 17, same idea, so let's go ahead and look at the coefficients first. So what's the greatest common factor of 41 and 3? That's another way of saying what's the largest number that divides into both terms, and that is there's only 1, so we don't have to write 1. And then we'll do the same thing with the powers there. So what's the biggest, the most number of h's we can factor out or divide out into both of them, and that is 4 of them. So again, I'll just copy down the original problem first, expression, and then I'll divide both of those by h to the 4th, and then simplify that. So that is h to the 4th. Okay, so we have 41 divided by 1 is just 1, and then h to the 6th divided by h to the 4th, there are 2 of those, and then minus 3, h to the 4th divided by h to the 4th is just 1, so 3 times 1 is 3. All right, number 18, 32z squared minus 24z plus 28. So on this one, we have two things we're looking for: the greatest common factor with the coefficients. So what's the biggest number we can divide into each of those terms? So the greatest factor of all of those is 4. Okay, and then again, we look at the variables. There's a z squared, a z, and then the last one doesn't have a variable, so it's not common. The variable is not common to each of the terms, so the greatest common factor on this one is only 4. So again, 32z squared, and we'll divide by the greatest common factor, minus 24z divided by 4, plus 28 divided by 4. And then we'll just simplify all those. So we get 4, and then 32 divided by 4 is 8z squared. And divide those two, 24 divided by 4 is 6z. And then that last one plus 7. So again, sometimes 16, 17, and 18, I guess the point of those ones is 16. Again, that greatest common factor can be a coefficient and a power. Number 17, the greatest common factor can just be a power. And number 18, the greatest common factor can be just a number. All right, number 19, what is the GCF of this one? So if we look at this one, 5 and 7, the only common factor is 1. And we look at both terms, and they both of them do not have a variable, so we can't factor out a variable. We can't divide by a variable. Okay, so the only thing, the GCF of everything is just 1. So on that one, we can say there is no other factors, so the word for that is prime, just like what we'd say a number like 11. 11 is a prime number because it's only divisible by 1 and itself. All right, the point of number 20 is when we look at each of these terms, so if we look at this whole thing separated by that addition, there is a factor that's the same. Again, factors are things that we multiply. And so you'll notice both of those have a 5x minus 7. And we'll practice this one a lot more on another class, but it's just getting this idea in our head that 5x minus 7 can represent a number. So it can be 2 or another variable a. And so we can divide out that out of each of those terms. So 5x minus 7, and we can divide that out of each of those terms. Actually, let me write this off to this underneath it. So we're going to divide this out of each term. So if I copy this entire thing again, plus 5x minus 7, and if I divide both of those terms by its greatest common factor, we'll see that anything divided by itself is 1. And so what we're left with, I should put parentheses around that first one, what we're left with is 7x squared plus 5. Okay, so you could almost see like that's being removed, and those blue parts are being removed, and what's left over right here is just these parts. All right, so that one's not that big of a deal, except for it's an introduction to factor by grouping, which we'll do later. All right, number 21. Sometimes we factor something. So if you're given this and I say factor, and some students look at this and say, all right, the factor is 2, and that is a common factor. The problem with that, though, is that that wasn't the greatest common factor. So if you make that mistake, you can obviously you can start over and say, you know, actually the greatest number was 4 that we can divide, or you can just do it again. So if you have that and say, oh, okay, both of those are even, so I could have factored out 2. So I'll keep that 2x there, and then I'll factor out a 2 again. So I'll change the color just to kind of emphasize that. So I'm going to factor by 2 again. So that's 10x divided by 2 plus 8 divided by 2. Okay, and this number out front, 2 times x times 2 is 4x. And then what we have is 10 divided by 2, which is 5x. And then 8 divided by 2, which is 4. Okay, so if you factor something that's not the greatest, you can either start over and say, you know what, I should have divided the very beginning, both of those by 4, or you can just keep factoring until you're done. All right, the last couple problems, we're going back, and those previous problems were all expressions that we were asked to factor. Now we're going to look at some solving. So number 22, if we just scan that real quickly, that's already factored for us because it's two things that, you know, we have two things that we're multiplying times each other. 23, there's no, that's not that way, so we got to think about that one a little bit. Now, to help us solve these problems, we have this rule called the zero product property, and this should make sense. So if we have two things that we're multiplying equal 0, that means one of those two factors have to be 0. So if the product equals 0, then one of the factors has to be 0. Okay, so for example, if I said 5 times something equals 0, what would that have to be? That has to be 0. And so we can do it either way. So on this one, once we see in factored form, we are set. We can say, all right, for this entire expression to equal 0, that must mean either that first factor equals 0 or the second factor equals 0. And then once we've kind of separated them, that should be easy to solve algebraically. Okay, you just do those inverse operations and then divide by 6. So x equals 4, and over here plus 2, and then divide by 3. So x equals 2/3. Okay, so those are our two values of x, so that the entire product equals 0. So on number 23, we'll use that information and our understanding of factoring to help us on number 23. So our first step on this one is we got to make sure it equals 0 when we're doing these, and it's probably best to do it where the factor is the biggest exponent, and we put everything on that side. So I'm going to add that to both sides, 11d to the 5th. So your step 1, you need to solve for 0, and that way it looks like number 22. So if I do that, 0 equals 77d to the 6th plus 11d to the 5th. Okay, step 2 is you're going to factor. Okay, so again, that's just what we're looking at. So what's the biggest number we can divide those coefficients by, and that is 11, and then d to the 5th is the most number of d's that we can factor out, both of them. This next step we'll just do in our head. So 77 divided by 11 is 7, and then d to the 6th divided by d to the 5th is d. And we'll do the same thing. 11 divided by 11 is 1, and then d to the 5th divided by d to the 5th is 1. Okay, and once we have that, step 3, again, this is just like number 22, set each factor equal to 0. Okay, so here's one factor, so 11d to the 5th equals 0, and then the other factor, 7d plus 1 equals 0, and we'll solve both of those. The first one, I guess you can divide by 11, but it should make sense. The answer is just 0. So what times itself? 5 times will get us 0, so d has to be 0. And on this one, that's a simple linear one, and then divide by 7, and there's our two answers there.